Today, I'm going to be solving 5 algebra questions, but there's a catch. Each question becomes pretty difficult as we keep progressing. And for level 5, oh my gosh, I'm not sure I'll survive. And I almost forgot to say this. If I lose this challenge, I'm going to be drinking all these waters right here with me if I fail, right? So let's get started with the challenge, y'all. We are in level 1 and this right here is the question for it. Pretty easy one. 2x plus 7 is equal to 19. What is the value of x? Now what I'll do first is inverse operation. I'm going to subtract 7 from this side and then this side as well. Why? Because I just want this positive 7 to cancel out this negative 7 and it's gone from the left hand side. So on the left hand side, I'm left with 2x is equal to 19 minus 7 is basically 12. And from here, I'm going to have to divide the coefficient of the x on both sides like this. And clearly this and this will go and I'm getting x to be equal to 2 goes into this 6 and goes into itself 1. Therefore, I'm left with 6 over 1, which is still 6. And I'm getting my x to be 6. Easy. We are in level 2 and this is the question for it. This is somehow easy, but it is more challenging than the previous one. How do we solve for x in this? Now over here, I'm going to be using the distributive property. What does that mean? I'm going to take this coefficient and then multiply by these two values inside the bracket. So I take it, I multiply, then I take it, I multiply again. 3 times x is giving me 3x. Then 3 times negative 4 is giving me negative 12. Keep in mind, this 3 is never affecting this 2. So I'm going to have to keep it like that. Then the right hand side will still remain the same. Now over here, I can just combine this before grouping like terms. It depends on you though. Cool. So I'll keep this. Then this plus that is giving me negative 10. And this is equal to 2x plus 9. Now there are 2 things to do right here. I'm gonna add 10 on both sides, then subtract 2x on both sides just to group like terms. And if I do that, I'm getting 3x minus 2x, and this is equal to 9 plus 10. And clearly we see that 3x minus 2x is giving me just x, and this is equal to 9 plus 10 is 19. And that is it for level 2. We are in level 3 and this right here is the question for it. If a plus b is equal to 10 and ab is equal to 21, what is the value of a squared plus b squared? Now, I know that a lot of people will do this problem by solving for a and b and then doing substitution right here. That will work perfectly, but I'm not going to do that because at least I know some of the algebraic identities. I know that if I have a plus b all squared, if I expand this one, I'm going to be getting a squared plus 2ab then plus b squared. And what do you see? You notice that this plus this is what we are interested. Why don't we make a plus b the subject? Then we do substitution. Because if you do that, obviously we will keep this one. We have a plus b all squared. Then we subtract 2ab on both sides and it will come here as negative. So this is it. Then we are getting a squared plus b squared. Look at that. We know what a plus b is. It is right here. And we know what ab is. It is also right here. We can do the substitution, right? So you've gotten the idea, right? So over here, we're going to be getting a squared plus b squared is equal to a plus b, which is giving us 10. So we're going to be getting 10 squared, then minus 2 multiplying ab, where ab is 21. So we're going to be getting 21 right here. Cool. Then we break things down. This is 10 times 10, which is giving us 100. So we have 100 minus 2 times 1 is giving me 2. 2 times 2 is 4. I'm getting 42. And if I subtract 42 from 50, I'm getting 8. And if I add the 8 to the 50, I'm getting 58. So here, I'm going to end up getting 58. Therefore, a squared plus b squared is giving me 58. That is level 3. So we are in level 4 and this right here is the question for it. if x squared minus 5x plus 1 is equal to 0, what is the value of x to the fourth power plus 1 over x to the fourth power? Now, at this level, let me say this, using the quadratic formula is not allowed. So how do we do this without a quadratic formula? Now, before we start solving at all, there is one good condition we have to state because it's really, really important. The condition is this. We are assuming that x is never equal to 0. Why this? This is because x is dividing something right here. If we don't assume that it's not equal to 0, then definitely we are sabotaging the system and we don't want that. So this is really important. And now that we have stated this one, I can just go ahead and then manipulate the question in the way that I want. So this is it. I'm going to copy everything down below, which is x squared minus 5x plus 1 equal to 0. And with the help of this, I can just go ahead and then divide everybody by x, even including this right here. Now, if we do this, you notice that this x will reduce the power to 1. So we are getting x, then minus this and this will go. So we have negative 5, and then plus 1 over x, and this is 0. Now you notice that at least we have gotten this term right here to be this x, and then this 1 over x to be this, just that we don't have the powers. And again, since we have a term containing x, a term containing x, I can decide to isolate them and then keep the constants in the other side. And I can only do that by adding 5 on both sides. So if I add 5 on both sides, definitely I'm getting x plus 1 over x is equal to positive 5, right? And at this moment, we have gotten all that we want, just that the powers are not the same. How do we achieve that? Since the powers are 4, we can just go ahead and then raise each side to the fourth power. However, we're going to be struggling along the way. We don't want that. So let's do it step by step. I'm going to be squaring both sides, just like this and like that. Cool. And with the help of one of the famous algebraic identities, we can expand this one. What is that? This is it. If I have a plus b all squared, this will give me a squared plus 2ab plus b squared. So using this idea, I can expand this so easily. I take this, I square it. So x squared is, of course, x squared. Then I multiply this, and that is giving me just 1. Then I multiply it by 2. And I'm getting just positive 2. Then I take the whole of this and square it. So 1 over x squared will give me 1 over still x squared. And the right hand side, I'm going to be getting 5 times 5, which is 25, right? So cool. This is it. Now, we have a constant right here. We can take it to this side. And how do we do that? By subtracting 2 on both sides. And if we do this, this is what we're going to be getting. We are going to be getting x squared, then plus that. So plus 1 over x squared is equal to, we are subtracting 2 from both sides, that is why this is gone. Then this will give me 23. So 2, 3 right here. Cool. One more step to go. We have x to the fourth power, x to the second power, but here we have x to the fourth power, x to the fourth power. What do? We square again. So I'm going to square here again like this. Then with the help of the algebraic identity, we can expand. So this is going to give me x to the fourth power. Then I multiply this and this, which is giving me just 1. Then times 2 is giving me positive 2. Then I square the whole of this. 1 squared is 1. Then x squared is x to the fourth power. X squared is x to the fourth power, keep in mind. Then this is equal to, now the right hand side is where things are really getting interesting. No calculator is available. How do we expand this one? Maybe I'll use the trick. It's not a trick even, it's an idea using the algebraic identity. I'm going to be getting 3 digits, right? From this one, that is the trick that I'm talking about. So the same idea, a squared plus a plus b all squared will give me a squared plus 2ab plus b squared. So we are assuming that this is of this form, even though we have 2 numbers together, but we are assuming that they are like this. So I take this one, I square, and what I will get is what will come here. Then I multiply the 2, multiply by 2, and it will be here. However, this side, even from here to here, they don't take double values, right? They don't take double digits. So if we get double digits, then it means that we have to move to the next one, right? So 3 squared is 9. 9 is a single digit. I can put it right there. Then I multiply 2 times 3 is 6 times 2 is giving me 12. I can put all the 12 right here. It will just take this value. So I'm putting the 2 right here. Then I carry the 1 to this one. Whatever I get over here, I'm going to add the 1 to it. So I take this value, I square. So 2 squared is 4. 4 plus this one is 5. And that's it. So it means that if I have this, then I square it, I'm getting 5 to 9. So what will be here is 5 to 9. We are almost done. And at this moment, we can just go ahead and then get rid of this on the left hand side. And we can do that by subtracting 2 on both sides. Cool. So we have x to the 4th power, then plus 1 over x to the 4th power. And this is equal to, remember, we are subtracting 2 from both sides. So 5 to 9 minus 2 is giving me 5 to 7. And that is pretty much it for level 4. So we are in the last level, which is the level 5, which is pretty difficult. Even though you can just look at it and guess the correct answer, however, at this level, guessing is not allowed. How do we solve? That is what makes it really, really challenging. So let's see about this. And if I'm not able to solve this one, don't remember or don't forget this one. I'm going to be drinking all this at this level. So how do we even start? Well, I know that this is an exponential growth, right? 3 to the power x, it keeps increasing, right? If x is greater than 0, right? Now, what I will do is that I'm just going to keep this term on the left-hand side and anything else on the right-hand side because this is the exponential growth, right? So maybe I will just put this one right here, 3 to the power x, and this is equal to 30. If we subtract x on both sides, we are getting negative x right here. That is it. And at this moment, what should I do? Well, I'll just go ahead and then divide both sides by 3 to the power x like this. 3 to the power x. And I know that for sure the rule of this will give me 1. So I'm getting 1 right here. And this is equal to, now we have a fraction. I can decide to split this fraction. However, looking at the nature of the fraction, if I split it, I think it is not going to give me anything, right? So I'm just going to keep this one, but I just want this denominator to move to the numerator side. How do I achieve that? Well, I can write this as 30 minus x, and then this 3 to the power x will come to the top right here to multiply what we have. However, the power will be negative. Keep in mind, the power will be negative. See that? Yeah, this is what we have. And at this moment, there is nothing I can do, child, unless I look further to something. What is that? I'm beginning of thinking of the Lambert W function, which basically works this way. If I have anything, let me use the red one. If I have anything at all, okay, and then there is e raised to the power that same thing, something like this. And if I take the Lambert W function on this one, I'm going to be getting the exact same thing, like this, right? So this is something that I'm looking at right here. How do I express the right-hand side to look exactly like this so that I can apply the Lambert W function? Well, it turns out that since we have 3 here and then we have 30 minus x right here, which in a way is 7 as this one, and is not equal to this, I'll try to get at least 30 minus x. And to achieve this one, what I'm going to do is that I'm just going to multiply both sides by 3 to the power 30. And here also by 3 to the power 30. And I know that at least the left-hand side is giving me 3 to the power 30. And this is equal to, here we have 30 minus x. Then, look at that. We have the same basis multiplying. If that happens, we can add their powers, right? So we're going to be getting times 3 to the power, we add the power. So negative x plus 30 could be written as 30 minus x, right? So we're going to be getting 30 minus x. Let me put these in parentheses. Cool. And now at least I have this and this which are the same. However, there is no E. It looks like this is acting as E, but it is not. We said that this should straightly be E. So how do we do that? Well, it turns out that I can write this in terms of E. Look at that. I will keep this 3 to the power 30 is equal to, then we have 30 minus x like this. Then 3, which could be written as e to the power ln of, then we're going to be getting 3 also to the power 30 minus x. Now, this is natural log. Of course, we can just take this power and then move it to the front. All right, and if we do that, let me do this quickly. We have 3 to the power 30 is equal to 30 minus x. Then we have e to the power ln of. Now, remember, let me put this first. We're going to be getting 30 minus x, then the natural log will follow. So bracket like this, then the natural log of 3. Yeah, this is something that we have right here. However, since the e came, the powers are no more the same. This has ln, this does not. They have to be the same. How do we achieve this? Now, since we have ln right here, I can decide to multiply both sides by that so that this guy will also get it, right? So here times ln. Let me put it right here. This side times ln of 3, and then this side also times ln of 3. And what I'm going to do here is that I'm going to bring this ln on this side so that it will look exactly like this. So let's see. Now, we're going to be getting this. I'm writing 3 to the power x, then ln of 3, like so. And this is equal to, I bring this one to this side. So we're going to be getting 30 minus x times ln of 3. Then we have e. So the e will come over here. Then the power is also going to be the exact same thing. So we're going to be getting 30 minus x, then ln of 3. Look at that. Now, since what is here is the exact same as what is here, I can just go ahead and then take Lambert W function. Not only on this, but on both sides. Remember, equation, we have to keep the system balanced all the time. So what I'm going to do is this. I'm not going to rewrite the whole of this again. I'm going to shift this one to this side so that I will get 3 to the power 30 ln of 3 is equal to, then over here I'm just going to put the w like this, then do the exact same thing right here. There we go. This is it, right? Now this, we can't do anything to it at this moment, so I'm just going to keep everything. W of 3 to the power 30 ln of 3, and the right hand side is going to give me one of these, which will be 30 minus x ln of 3, and of course this is in bracket. This is what we have. However, this Lambert W function is disturbing us. Let's get rid of it. So here, this is what I can do. I can just rewrite this 3 to the power 30 in different form. What is that? This will be w of, I can split this one this way, 3 to the power 3, then times 3 to the power 27, then ln of 3. And the right hand side, we are done manipulating it. Therefore, we're going to be keeping it as it is throughout. Cool. Now, I'm going to express this one in a different way. Look at that. 3 to the power 3, of course, is 27. And this is 3 to the power 27. So this is what I'm going to do. I'll get rid of this w. And this is the deal. We have w of, I know that this is giving me 27. Then I'm going to copy this and paste right here. ln of 3. Then this 3 to the power 27, I'm going to rewrite it in terms of e. In my head, I just want to get rid of the w. So this will give me e ln of this right here, which is 3 to the power 27. And y'all know that because we have ln right here, we can move it to the front, right? So I'm just going to get rid of this and then paste it right here. So 27 like that. Then the right hand side is going to give me the exact same thing, 30 minus x, then ln of 3. There we go. Now look at that. What is here is the exact same as what is here. Therefore, I can get rid of the W by writing one of these because they are the same at the moment, right? So this time I'm gonna be getting 27 ln of 3. Now let me change this one to the black one so that it will be obvious. 27 ln of 3, and this is equal to 30 minus x. Then we have ln of 3. And clearly we can get rid of this ln of 3 if we divide both sides by that, right? So straight away you notice that this and this will go if we divide both sides by ln of 3, right? And we are left with 27 is equal to 30 minus x. And at this moment, I'm beginning to laugh because I'm not drinking the water. Let's see. Now, how do we figure out x? It turns out that we can just bring the x right here, and this will be 30 minus 27. And ladies and gentlemen, this implies that s is equal to positive 3. This is what I've gotten right now, but I'm not sure if it is indeed the correct answer. So I have to verify. Once it works, then it means that I'm not gonna drink these waters just to pass my stomach, you know. So let's put in x to see if we have gotten it. X is 3. So when x is 3, we're going to be getting 3 to the power 3 plus 3. And in the end, we have to get 30. 3 to the power 3 is 27 plus 3 is giving us 30. And it turns out that indeed this is the answer to the question. And as you all know, this is not as easy as we all think, right? So that is it. And this brings us to the end of the challenge. Fortunately, I didn't lose, and therefore I'm not gonna drink the water. Thanks a lot for watching. If you found the video useful, make sure you give me a thumbs up, subscribe to the channel, share to your friends, and I'll be more than happy to see you again right on this channel. See you again. This is Mesh. Bye.